Let me start off this video with saying I don't like this test very much that I'm going to show you, but I've been thinking about how to go and get fine dust extraction results for water-based vacuums. So with the equipment that I have on hand, this is probably about the best I can do at the moment, unless I manage to think of something else. So let's go over this here. I have 10 grams of baking soda and another 10 grams of baking soda. And I'm going to put all 20 grams of baking soda down in this carpet. Now right away you should say, no, that doesn't make any sense because you've doubled the dirt density. Well, I'm going to take this amount of baking soda, which is twice as much as I normally use, and I'm going to spread it out. Instead of cramming in about 10 grams in, say, maybe a square foot, slightly over a square foot, I'm going to put that amount of fine dust in double the amount of carpet, about 2 square feet or so, maybe 2.5 square feet, so that the dirt intake rate should be about the same. And that's really important. If I were to just go and put twice as much dirt in the same amount of carpet, it would really invalidate my whole series of testing. So there's that. The other problem you have with measuring, it's just so weird. I've done so many tests with this, with water evaporation rates, but we can call this, say, water destruction rate. If I go and I fill that bin up with nice, clean, clear water right up to the top of the stick, and I turn the machine on, and I run it for the same amount of time to do 2 full cycles in the carpet, on average, this machine loses about 1.92 grams. That's just by turning the machine on, not picking up any particular dirt, and then turning the machine off again, and then remeasuring the water loss in the bowl. So there's that. So let's start out and see what we can do with this. If you are less than thrilled with this type of testing methodology, I'm right there with you. I prefer to do what I term as a direct measurement. There's a bin, I can measure the bin, I can measure what comes out of the bin. If there's a bag, I can easily measure the bag. With this one, I can measure the bowl, but the problem is I can't separate the fine dust from what's in the bowl. So I have to measure the whole thing, and frankly, when you use a rainbow, water sloshes. So I'm going to try to do the best I can really do, and let's see where this test takes us. Okay, let's take a few measurements. I need to find out what the empty bowl weighs. All right, stop wiggling. And I think you guys can see it from this angle. Yeah, you can. All right, I'm going to call it at 651.3. I know it might bounce a tiny little bit. Yeah, still pretty stable. That's nice. I'm going to put in 64 ounces of water, which is going to be 1814.4 grams. And the total that we're going to be looking for, if I take 651.3 plus 1814.4, should be this. So 2465.7 grams right there. This is going to take me a minute, and if I end up putting a little too much in, I got a scoop to get some of it out. You can also use like a turkey baster. All right, let's see how long it takes for me to get this up to 2465.7. I have to do this without spilling too. Let's see. Ha! Finally. Yay! 2465.7. That took forever. Here we go. Time to get the board of measurement. My excitement mounts. I have tested sand. I have never tested fine dust. The sand was easy to do because I could easily separate it. But the baking soda, not so easy to separate. Okay, we are zeroed. Let's see what the total weight is. I have to take a second for the water to settle. And I think you can see that. Come up a little bit more. Okay, let me make sure that I have a decent focus there. And we ended up with 2468.8. So let's put that in the calculator, and then we will subtract 2465.7. And this is what we get. Now, this isn't out of 10 grams. This is literally out of 20 grams. If you wanted to see what was in the bowl, there it is. To get a more accurate representation of what this D4C SE managed to pick up, I need to take 3.1 grams and add back in my known average water loss of 1.92 grams. If I do that, I get 5.02 grams, but when I calculate a percentage, I have to divide that by 20, not 10. So you can see I get 0.251, and if I move the decimal place, that ends up being 25.1%. Let's put this into perspective for a minute. This D4C SE from 1993 beat these three vacuums: the bagged Simplicity Symmetry, the bagless Wind Tunnel 2 Whole House Elite, and the bagless Power Force Turbo. Now for the bagless machines, I am comparing apples to apples, that is raw bin pickup, because let's face it, I wasn't able to extract fine dust from that bowl. So there you go. And looking at this shot, the way it's framed, the three machines that it beat that I've tested so far with the 2-cycle fine dust test are all red. So you could say classic brown beats red. So I know I have an awful lot of baking soda still left in this carpet. So let me get a bagless system that does pretty well with baking soda so I can show you how much still remains in this carpet. in there. And now for the dump. Now, this machine isn't going to pick up all of it. I'm going to have to use a higher CFM machine. This machine limits out at, probably around 75% or so. So this machine won't get it all. You can kind of see what's left. So there's a bunch left, and yeah, it's not perfectly white because there's still some carpet fibers left in there, but there's still a lot left in there. So the rainbow did leave a bunch in the carpet. It's not some kind of magic trick I just performed. All right, thanks for watching. I'm ready for all the negative rainbow comments. Here's a closer look at what came out of the shark. Obviously, I separated more of the fibrous material from the baking soda, but you can still see there's an awful lot that came out.